Okay, so here we're looking at rules of exponents is what we're doing here. These are rules of exponents. So we want to understand that these rules are really just shortcuts. All they are shortcuts because essentially when we look at an exponent is essentially a shorthand of multiplication. So an exponent just tells you how many times to multiply the base to itself, okay? So like when we're looking at x to the fourth times x to the second power, what does that really mean? Well, in its expanded form, x to the fourth means x times x times x times x. And then x squared means x times x. And so if we were to simplify that again, basically means putting it back in exponent form, what would we have? Well, 1, 2, 3, 4, 5, 6. We would have x to the sixth power, basically using the definition of an exponent. So what the product rule does is the product rule tells us, well, you don't have to list all the variables out like that. You can do a shortcut, which is simply add the exponents together. So x to the fourth times x squared, because the bases are the same, it would just be us basically writing out these x's and counting how many we have. So instead of writing it out, you can just add the numbers together. So 4 plus 2 is 6. So you get x to the sixth power. And that's how you use your rules. So the rules, remember, are just shortcuts for us, okay? So here we have x to the sixth over x to the fourth. So essentially, we are looking at a division problem here. But we're still going to use our rules of exponents to show what it looks like in its expanded form, okay? X times x times x times x times x times x over x times x times x times x. So when we look at this, essentially what we're supposed to do is we are supposed to look and say, okay, well, it's basically a fraction. So I would need to simplify this fraction to lowest terms. And so if we understand about cancellation, when we cancel fractions, when we learn fractions, you cancel 1 to 1. So I can cancel x to x, x to x, x to x, x to x. What does that leave me with? Well, it leaves me with x times x. Well, x times x, written in its exponent simplified form, will be x to the second power. Okay? Now, what the quotient rule says is, who has time to write out all those x's? Now, you can choose to do that if you want and just cancel and you'll get the same answer. But the quotient rule is there for you to be able to do it faster and just be able to get straight to your answer. So I have x to the sixth over x to the fourth. So what is that? It is the top exponent minus the bottom exponent. So x to the 6 minus 4, which is x to the second power. So you still end up with the exact same answer. Okay? Next we have the power rule. So the power rule here says x squared raised to the third power. So in its expanded form, if we were to understand the definition of an exponent, we have a base here. The base is x squared, and x squared is being raised to the third power. So what does that mean in its expanded form? It means x squared times x squared times x squared. Okay, now once you get here, it's just a bunch of multiplication, so you could use the product rule above, but we're just doing it in expanded form because I want you to understand that the rules are just shortcuts. So x squared times x squared times x squared, so that means x times x times x times x times x times x. So we expand it just so we can simplify it again. That's why the rules are so helpful. So if we just count 1, 2, 3, 4, 5, 6, we see that we have x to the sixth power. Now, what the power rule says is you don't have to write it out all like that. You can just multiply the exponents together and you will get the same outcome. So if we have x squared being raised to the third power, then we are doing x squared times a 3 gives me x to the sixth power. Same thing. Okay? Now, you also have the option to understand and expand it, and then x squared times x squared times x squared is just 2 plus 2 plus 2, which would still be x to the 6th power. Okay, so the rule still, you can choose to incorporate it whenever you understand to incorporate it. Then here we have the power rule, quotient power rule. And so essentially you have the quotient here, x over y, with the exponent out here. So essentially the power rule, these are exponents of 1 on that x and that y. So x to the 1 times a 2 over y to the 1 times a 2. So this exponent here, the 2, must distribute to the x and the y. And we apply the power rule, meaning we just multiply the exponents together. So we get x squared over y squared. And we cannot simplify that anymore because the bases are not the same, which means what? They wouldn't be able to cancel. That's what the fraction is. It's just a cancellation if the bases are the same. Then we have x to the y, x times y raised to the 3rd power. So again, in its expanded form, it would be xy times xy times xy. And so what would that be? So that would be x times x times x times y times y times y. So you just rearrange your variables so that you can understand. And so what is that? That's x to the 3rd, y to the 3rd. But again, why are you expanding? Just so that you can condense it again. So here, we can just apply the power rule and essentially distribute that exponent to each exponent that's present. So x to the 1 times 3, y to the 1 times 3, which gives us x cubed, y cubed. And that's exponent rules.